Welcome to another episode of Code for Thought. Now, who hasn't worked with Jupyter and Jupyter Notebook at some stage in their career? I know I certainly have. But in this episode, we look at Jupyter Hub. Jupyter Hub is a way of running Jupyter on a range of different environments and cloud services. Meet Sarah Gibson, who works at the International Interactive Computing Collaboration, or 2I2C for short. And she and her team develop and operate Jupyter Hubs in the cloud and deal with the infrastructure behind them so that we can all focus on our teaching and research projects as we should. Sarah takes us through what it takes to run an open source service as well as the benefits of using Jupyter Hubs. And here now my conversation with Sarah. Hello everybody, and hello Sarah. Sarah, thanks very much for your time today to talk us through Jupyter and your work there. But before we start, could you introduce yourself?
Yeah, hi everybody. My name is Sarah Gibson. I'm currently working as an open source infrastructure engineer at the International Interactive Computing Collaboration, or 2I2C for short. At that organization, I'm deploying Jupyter Hubs for people in research and education groups. And I've been a member of the Jupyter Hub subproject team for about 2 years now. Working on that infrastructure and also part of the Binder project as well. And I help run myBinder.org, which is a website for sharing and building reproducible computational environments on the fly.
So thanks very much for the introduction, Sarah. Most listeners will probably be familiar with Jupyter and Jupyter Notebook, but just for the sake of doing a little bit of explanation up front, could you give us a high-level overview of what it is?
Jupyter Notebook is a tool for what we call literate programming. So this is mixing prose and code together in one document, sort of along the lines of an electronic notebook or an interactive paper or something like that. Usually just reading the code alone isn't enough context to explain what you're trying to do in the code, and we often write comments, but in papers or maybe tutorials, it goes more in depth like that. So that was the goal that Jupyter Notebook was trying to solve when it was first thought up. It was originally called the IPython Notebook when it was first developed, but there was actually nothing in the code base that was Python dependent. And that is then how we grow into the Jupyter ecosystem.
Oh, right.
So for those not in the know, Jupyter is actually it's sort of like a portmanteau of three very popular open source programming languages, which is Julia, Python, and R, Jupyter.
Oh, that's where it comes from. Okay.
Yeah, exactly. There's like an extra little bit where the E is like the E in Notebook, but I'm a little bit like that's stretching the acronym a bit far, in my opinion. So Jupyter then grew into this much greater, richer ecosystem of people who care about data science and want tools to make doing data science easy and that are like not language specific. So this includes other interfaces such as Jupyter Lab or RetroLab or a lot of the Jupyter Lite or some of the other cool interfaces that are coming to the fore at the minute. It also includes our widgets ecosystem that can provide add-ins to do interactive plotting or bring in databases, all of this kind of thing. Yeah, so it's a much richer ecosystem of people doing data science, really.
So you already alluded to that it's a broader ecosystem now. I mean, I started using Jupyter Notebook with Python mainly, which I think is probably the most dominant language, maybe. Maybe I'm wrong because it's almost the lingua franca of data science today. Or what is your understanding of that? How does it actually split between the three different languages, Julia, Python, and R?
So we have a collection of kernels. Kernels is the bit of the Jupyter infrastructure that is actually executing code. And whenever you open up a notebook, like the raw.ipynb file, you'll notice it's a JSON file. At some point in that JSON file, there'll be a key that is kernel and it describes the language that notebook needs to be operated in, and that links to a Jupyter kernel where that language is supported. So it basically grabs that kernel and launches it up. So we have kernels for Julia, we have kernels for R, and we have kernels for Python, but there's also kernels for Fortran. And for like Octave, which is an open source version of MATLAB, the list of kernels supporting languages is like so long. The only thing I can recommend for you to do is to Google Jupyter kernels and see if your favorite language is represented there.
But chances is it probably will be.
If there are enough people using it in data science in the Jupyter ecosystem, probably, yeah.
How successful is Jupyter today in terms of how many people do you think are using it? Do you have any visibility regarding that?
It's always a really difficult thing, I think, to track usability of open source projects, especially if you want to be privacy mindful. There is a project that basically scrapes GitHub to see how many Jupyter notebooks are available on GitHub, for example. And I think the number is in the millions. You can look at how many launches myBinder.org has. And again, that's like, well, we've just done a load of work to reduce our amount of launches in order to save some cash, but it's still like hundreds of thousands per month. But in the case of like, where is Jupyter deployed in places that's like not open, so like private companies, like we don't know that until they come and tell us. But for example, I was a co-chair of the Jupyter and Enterprise track at JupyterCon 2020, and we had talks from PayPal and like banking companies about how they use Jupyter in their workflows. It's very dominant, I think, in data science at the minute, for better or for worse, I think.
So I think that is a nice segue into the next set of questions that I really have. So what kind of typical workflows do you have in mind when we talk about Jupyter Notebook and the use of it in data science?
I think this comes back to what I mentioned before about notebooks being literate programming, and that you can explain what you're doing as you're going along. That just makes it a lot easier to collaborate with people, to onboard people quickly into what your notebook is doing. There's like a range of different workflows that supports. It supports like tutorial-based learning in classes. It supports reproducible paper publishing. It supports like rerunning workflows and explaining that workflow as you go along. And I think that's also sometimes its downfall as well. We sometimes become reliant on that literate programming, and it blurs the boundary between when you're quickly developing code. Doing it in a notebook is nice because you don't have to rerun all of the code. You can execute cells separately. So if you have a long running task, you can like run that once and then the result of that is stored in state. But there's like some point on the development timeline where transforming that notebook into a script or a library becomes more useful. And I think that becomes less clear. I think sometimes you find notebooks that should have been cleaned up into modules, and other times it's perfectly fine to leave code in notebooks as it was. Like, I don't think either approach is specifically right or wrong. It's what scenario you are using that code in as to whether you leave it in a notebook or not. And that line has just got a bit blurrier, I think, especially as we run into more collaborative workflows.
There is this kind of two-stage problem typically that people start prototyping some code, and very quickly using, for instance, Jupyter Notebook. And then when it comes to performance and actually rolling it out in seriousness and in anger, they have to then do it all over again in a different programming language. When you talked about workflows, you actually focused on tutorials and explicit code. But do you also see that Jupyter can be used in earnest, say, in production systems? Or is that something that you feel that Jupyter is not yet geared up for, except for Julia, which has the reputation of being performant as well as being intuitive?
There are definitely tools out there that will run Jupyter notebooks in a production environment. For scalable computing in the cloud, there is a tool called Kubernetes, and Kubeflow is a package that you can run on top of that, which will kind of deploy your notebooks into a cluster to be scaled and stuff like that. I believe there are products out there that solve that problem of deploying Jupyter notebooks in production environments, which proves that there's a need. Otherwise, these people would not have been bothered wasting their time creating the tools. Again, I don't want to say whether that is a correct or incorrect workflow, because I think I would need to know more about the specific situations they're being deployed in, but there's obviously need for it.
Let's talk about Jupyter Cloud, because we talked about it for a while, or at least we mentioned it a few times. Let's start by explaining what it actually is.
So we don't really refer to anything specifically as Jupyter Cloud in Project Jupyter. So what I might do is I might answer a slightly different question first, which is, what is a Jupyter Hub, which is the specific sub-project I am a team member of. A question that you have a lot in collaborative working environments is, I might have a set of computers and there are a group of people that I want to provide access to these computers via. And a Jupyter Notebook or Jupyter Lab is a good interface for them to access those compute resources. The solution to that problem is a Jupyter Hub. And there are two key pieces of infrastructure inside a Jupyter Hub. One is its authentication systems. The other is its spawning systems. Its spawning systems are how it asks for compute resources, what type, what size, and who is asking for them. And then the authentication is like, who are you? Do you have rights to access my environment? Between these two things, you can map any subgroup of users onto any subgroup of computational resources you like, just by picking the right authenticator and the right spawner. So this could be university students on university servers. It could be anonymous users in the cloud. It could be researchers on HPC. So that is what a Jupyter Hub is in its essence. We, the Jupyter Hub team, distribute two types of Jupyter Hub distributions, basically all packaged up, ready to go. One is called the Littlest Jupyter Hub. This is designed to run on a single server and support up to 100 users. The other distribution we manage is called Zero to Jupyter Hub on Kubernetes. This is the distribution of Jupyter Hub that you can run in the cloud. And it runs on this tool called Kubernetes that I mentioned before. That is an open source tool that was originally developed by Google. And it's basically an abstraction layer that allows you to have a group of machines working together as a cluster. And then you put the Jupyter Hub on top of that, and it can spawn servers in that Jupyter cluster for a given user. And what that allows you to do is dynamically scale, depending on the amount of traffic visiting your Jupyter Hub at the minute. So instead of like a fixed resource, which is a computer of this size, it's always on, you can increase the number of machines you have at any point, decrease them. You can even have different types of machines. So maybe you have a special set of GPUs that some people can have access to. So when we talk about using Jupyter in the cloud, we are usually talking about running the Zero to Jupyter Hub on Kubernetes distribution in the cloud.
I think what I'm taking away from it, it's when we say in the cloud, it's actually not just in the cloud. It can run on a single computer, as you say, which is what a lot of people do anyway when they install Jupyter Notebook. But they can also run it in different systems like universities or a company's HPC cluster. Or they can go, in fact, to commercial cloud providers like, the typical big three.
Exactly.
And you can probably also think about hybrid solutions where you have a situation where university may have on-premise HPC cluster and then also something maybe in the cloud. Or would that be pushing it a little bit too far?
I think there are multiple solutions on how you could do that. For example, I know the University of California, Berkeley has what they call a data 8 environment, which is actually many Jupyter Hubs running sort of like parallel. So long as you're communicating very clearly to your user base how you access the cloud Jupyter Hub versus how you access the on-prem or the HPC Jupyter Hub, and so long as you have the resources to maintain all of those Jupyter Hubs, there should be no issue in that.
Since you're involved in Jupyter Hub, so can you explain what your role is there, what you're looking after and what you're doing there?
Yeah, it's like typical open source working there. So I think the main thing that my teammates will say that I do is I often facilitate our monthly team meetings and make sure we're getting updates from everybody. The team don't actually work too close together until we're like developing a feature or fixing a bug directly in Jupyter Hub. So a lot of my contributions come from when I'm working at 2I2C, fixing a Jupyter Hub for a specific community there. If the fix is generalizable and welcome, then the right place to put that fix is upstream in Jupyter Hub. So I guess my responsibility is just being a good open source community member, making sure my intentions are clear when I submit new features, helping people onboard themselves to the project and such.
So what are the challenges, the typical challenges? I mean, you're looking at it from the other side. So there are the challenges for the users, obviously dealing with Jupyter. But from your perspective, how do you keep it all together? What's keeping you awake at night in terms of Jupyter?
At 2I2C, we are running a lot of Jupyter Hubs for a lot of different communities, ranging from large communities like Pangea down to individual community colleges in Berkeley, so much smaller user bases. And we've tried to reduce the amount of time we spend awake at night by centralizing how we control all of that infrastructure. We can deploy something like 40 Jupyter Hubs from one GitHub repository using various Python code and CI/CD workflows. So the things that keep me up at night are like flaky health checks, like making sure the hub is still awake and alive and responding, and that test not being reliable and not trusting it, because what's the point of having a test if you don't trust it? So we need to do some work to improve that. Other things are outages. So we have a support system when authentication isn't working how it's supposed to, or node spin-ups aren't happening, and people actually physically can't get on with their work or even access the Jupyter Hub. That's a worry. And we learn something new every time one of those outages comes in. It's not always something to fix in Jupyter Hub. Sometimes it's something hit maximum and we weren't told, like disk space or something, and it just stopped, and we need better monitoring systems or things like that. Like Jupyter Hub on Kubernetes is abstracted enough that you can deploy it onto any Kubernetes managed service on any cloud, but that doesn't mean they are all created equal. So obviously the big three have like the most mature and stable Kubernetes services. DigitalOcean is another one that is quite reliable and isn't one of the big three.
So when it comes to keeping you up at night with issues that you just mentioned, is one of the issues potentially also attacks from outside and seeing if Jupyter and Jupyter Hub can be misused for nefarious purposes?
This is a common problem on myBinder.org, in that we get crypto miners and Bitcoin miners a lot. And some would say, well, that's the price you pay for having unauthorized access to cloud resources. So for me specifically as well, having like access to resources that aren't controlled by a specific institution is very powerful, I think, in terms of democratizing access to infrastructure. Like, I hear stories about people in the global south who don't have the ability to access some of the resources that the big three put out, and they rely on mybinder.org because it's available there and isn't as restricted there as some of the other clouds are. And that just brings me joy, right? We're bringing resources to people who would not otherwise have access, so that they are able to learn and explore. In terms of the Jupyter Hubs, we're often running them for specific communities, so we have authentication as such. It's a lot easier to track down who is doing the bad thing and ban them, but no one has done the bad thing yet.
Good.
But on mybinder.org, it's a much more prevalent problem, and we're thinking about ways that we can mitigate that issue while still trying to provide a service that might not look how it's looked for the last 3 years or something, but we care very deeply about having open access to these kind of things.
The fact that it is flexible and runs on multiple platforms, if you like, is probably also potentially a safety mechanism.
You would definitely have downtime if you were moving a Jupyter Hub from one cloud to another. But Jupyter Hub has something called network policies built in, which is actually piggybacking off Kubernetes network policy. And that's actually how you define what is and isn't allowed to come in from which IP addresses and using what kind of protocols. So rather than, oh, this Jupyter Hub has been attacked, so let's move it to a different cloud, I would probably restrict the network policies first before considering moving it. However, that being said, the fact that Jupyter Hub can be deployed onto any cloud provider is a huge advantage. You're not getting locked into a specific vendor. If tomorrow Google said we're not managing Kubernetes services anymore, that doesn't mean you can no longer run your Jupyter Hub. You will have to move it, and that involves labor, but it's like not the end of the world.
Okay, you mentioned network policies. I would imagine that coming up with a good network policy and kind of diverse platform ecosystem is quite a difficult thing. So how would you approach that?
Oh my gosh, it is really, really hard. And network policies are probably one of the most conceptually difficult things in Kubernetes as well to think of.
What's so difficult about it?
They're additive. You can't merge policies very easily. So it means you end up repeating blocks of code. There's also no explicit deny. There's only allow. So you have to understand what you want to achieve very, very well, and also understand the mechanisms you have available to you to be able to apply them in such a way that you get to your end state. In my experience, it just requires a lot of mental gymnastics to get there. Okay. And you also have two systems to think about. There is the internal network of the Kubernetes cluster and different containers talking to each other. And some containers should be allowed to talk to each other. Some containers shouldn't. Some containers should, but you should have to authenticate first. And then there's the rest of the internet and the outside world to think about. We don't want to be restrictive on how scientists using the platform. When I say we here, I'm talking about to I2C as well. We don't want to be in a position of managing our own mirror of the Python package index because we have completely shut down access to the internet, for example. It's a balance of what is the correct amount of access that allows people to get on with their work without needing an engineer in the loop. 2I2C has its own opinionated network policy that we deploy with our Jupyter Hubs. And if you deploy your own Jupyter Hub in the cloud, you can define your own network policy as well. What I'm talking about now isn't anything that's specifically baked into Jupyter Hub unless it was deemed a security risk and should be.
Well, I guess when it comes to open services generally, or anything that goes to the outside world, security issues and network policies is a very tricky thing, full stop, I guess, independent of Jupyter. I think we should add that. But which is a nice segue into another and probably the final question for today. How easy is it to actually set up Jupyter Hub, and what help do I get?
Setting up a cloud-based Jupyter Hub, it's not trivial. You'll need to have a cloud account of some description. You'll need to be able to use their managed Kubernetes service to create a cluster. Installing the Jupyter Hub onto that cluster uses something called Helm, HELM. I don't know if this analogy is 100% true, but it helps me think of it. So Helm to Kubernetes is a bit like pip to Python in that you can use Helm to install applications onto a Kubernetes cluster using YAML configuration. And that is what the Zero to Jupyter Hub on Kubernetes repository is. It's a Helm chart. There's a very nautical theme in Kubernetes. Kubernetes is actually Greek for captain or helmsman or something like that. And then helm is you're at the helm of your boat. In older versions, there was another component as well called tiller, which is the thing underneath the boat, and it was actually the thing running on the cluster that you could talk to.
Somebody did their Greek
Somebody
history.
Somebody did their Greek history and pulled together all of the concepts very nicely. Right. You would install the Helm chart onto your Kubernetes cluster, and then you kind of have a Jupyter Hub. The question is then providing specific values configuration to tweak it to exactly your needs. And then you can get into like DevOps, CI/CD realm of how you keep that Jupyter Hub up to date with the configuration that you've tweaked. This is why we've consolidated all of that to I2C's config into a single repository, because it's easier to manage. We have CI/CD that does the deploys when we hit merge. There are a lot of guides on the Zero to Jupyter Hub website that tell you how to configure specific things for your needs, and like different types of authentication methods, and optimizing the Jupyter Hub for scaling and such, and what to do with like storage and all of that kind of thing. We have a discourse forum, and a few Gitter channels as well, where people ask questions and we try to answer. The discourse forum is probably better for that because it's persistent, and you can see like a lot of questions have been answered by that before. And there's just like a load of knowledgeable people that hang out there. That would be where I go for support in running Jupyter Hubs.
So how long has it been actually running then? You mentioned several years.
I don't actually know. Like long before my time. Compared to like the Jupyter ecosystem as well, like we can say, like you could look back at Fernando Perez's email or Git commits and say, okay, well, IPython notebook started then, and then everything kind of expanded. And because there are so many different sub-projects under Jupyter, it's really hard to like disentangle your history timelines. But it's been a good few years.
It's also open source, and which I think is quite important. It allows people to actually see what's happening code-wise, but it also allows people to contribute to it. So how does this contribution then work? I guess that there are a lot of contributors that you have, and how do you manage all of that?
With varying degrees of success, I would say.
Okay.
As ever, we are majoritively a volunteer team. Majority of us have full-time jobs. Some of us are lucky enough to have full-time jobs that either support us contributing or contributing to Jupyter Hub are direct, like written into our job descriptions. I am one of those very fortunate people where contributing upstream to Jupyter Hub is well within my job description. The issue comes with issue triage and reviewing pull requests in time. Sometimes we see far enough down the road that a feature needs to happen and we can plan and coordinate. Sometimes we are more reactive to, say, security issues or things like that, and we have to push things out. One thing that might help in this is that last year, Chris Holdgraf, who's on the team as well, and myself won a grant from CZI that will be able to put me in a community strategic lead position in the Jupyter Hub team. And that will be thinking about exactly these kind of processes, like how does our community work together? Is that effective, and what needs to change? How do contributors arrive at our project? Is that effective, and what needs to be changed? How do those new contributors get to grow through the project? Is that effective? What needs to change? So I'm hoping in a couple of months, when that project kicks off fully, I will be able to spend some more time deep thinking about this and help the team put in some more processes so that we can be mindful of how we accept these contributions and triage these contributions, while also being respectful of the amount of volunteer time that is being input.
That sounds like a formidable challenge.
Yes.
You got your work cut out there. So in general, so what do you think lies ahead for Jupyter and Jupyter Hub?
We have so many blue skies, amazing conversations about what could happen. I think so long as there is an open source vendor agnostic option, and so long as there is a need for people to not want to be tied into a specific cloud provider or want an open source solution, there will be a need for Jupyter Hub. Then our mission becomes, how can we provide a similar like user experience compared to non-open or proprietary services that are backed by big companies that have way more resources funnel into their service and push out features really quickly? How can we provide a service that is good enough in terms of usability that it remains worth it to choose it over one of those other services? That's not always feature parity. That's not always speed or like the size of storage you provide. Sometimes that is the flexibility in being able to customize your environment or move it around. So I think those are the questions that we'll be facing Jupyter Hub. What areas do we think we need to improve such that people still want to use Jupyter Hub and we don't fall so far behind that we're no longer a viable alternative?
Thank you very much, Sarah, for this fascinating interview. And I wish you all the best for the future.
Thank you very much for having me. It's been a great chat.